Hello boys and girls, Mr. Giomini. I want to take a look at two questions that you could possibly see similar examples to on the Chapter 2 midpoint assessment. Let's take a look at number one. 3 clocks ring once at the same time. After that, the first clock rings every 3 hours, the second after every 4 hours, and the third after every 5 hours. After how many hours will they again ring together? Let's go back to this. There's 3 clocks. Now, at once, they ring at the same time. After that, the first clock rings every 3 hours. So we have the first clock ringing at every 3 hours. We have the second clock ringing every 4 hours. And then we have that third clock ringing every 5 hours. Now, how many hours, after how many hours will they again ring together? Now, it's not what time will they ring again, it's how many hours later. So we have clock 1, I'm going to call it C1. We have clock 2, and we have clock 3. Now, we know that clock 1 is ringing 3 hours, and then again 6 hours, and then again 9, and etc., etc. We have this one 4 hours, which then it would be 8 hours from the original start time, and then 12 hours. And then we have clock 3, 5 hours, then 10 hours later, then 15 hours later. Looks like I'm listing multiples here. So what I'm really looking for is the least common multiple for 3, 4, and 5. Now I can continue to list all the multiples for 3, all the multiples for 4, all the multiples for 5. What I'm going to do instead, and it's not because I'm smart, it's because I know a little bit about numbers and I work with them a lot, I'm going to really just list the multiples of 5. Because I know that 3 and 4 have to be a factor of whatever that multiple of 5 is. Now, knowing that the multiples of 5 are 5, 10, 15, etc., I need to look, well, is 4 a factor of 5? No. Well, I need to know about the numbers that are divisible by 4. And numbers that are divisible by 4 have to be even. Well, the only even multiples of 5 end in a 0. Meaning I could eliminate all the numbers that end in a 5, or have a 5 in the ones place, for the multiples of 5. So let's just take a look at the even multiples of 5. So we have 10, 20, 30, 40, start back up here, 50, 60, 70, and 80. Now I'm going to look at 3 and 4, and I'm going to look at each number and say, wait a minute, are 3 and 4 a factor? Meaning, can I multiply something by another number by 3? Can I multiply something by 3 to get 10? Can I multiply something by 4 to get 10? Well, neither of these numbers are a factor of 10, so I'll cross it out. Now 20, 4 is a factor of 20, 4 times 5, but 3 is not a factor of 20. I will cross it out. Remember, it needs to be a factor, it needs to be a multiple of both 3 and 4. So 3 and 4 both must be a factor of this number. Again, 3 is a factor of 30, but 4 is not. Cross it out. 4 is a factor of 40, but 3 is not. Go to 5. Well, 5 plus 0 equals 5. That rules out 3 because 3 is not a factor of 5, or it is not a 5 is not a multiple of 3. I'll cross it out. Now we get to 60. Let's add it. Well, I know that 3 is a factor of 6, so it works for 3. Now does 4 go into 60? I don't know off the top of my head, so let's try 60 divided by 4. What times 60, or what times 4 gives me 60? Well, we'll put a 1 up here. I subtract that, gives me 2, bring down a 0. 4 goes into 25 times. Look at that. 15 times 4 does indeed give me 60. That means 3 is a factor of 60, 4 is a factor of 60, and so is 5 because these are all the multiples of 5. What I would do now is type out a little sentence. You would write it out. So again, after how many hours will they again ring together? After 60 hours, or I could even say 60 hours later, all 3 clocks will ring at the same time. Okay, hope that one helps you out a little bit. Again, I'm using the LCM, least common multiple, which, going back to when we did this activity in class, many of you started to work on this, and that was good to see that you were kind of going this route. Let's take a look at the next one. A combined class of 6th, 7th, and 8th grade students was assembled for a mathematics skills development workshop. The organizers seated the students in the order of grades and seated the same number of students in each row. If there are 48 6th graders, 40 7th graders, and 32 8th graders present, how many students were seated in a row? Let's go back and take a look here at what we have. A combined class of 6th, 7th, and 8th graders. Okay, so we combined a class of all those 3 grades. The organizers seated the students in the order of grades. In the order of grades. Meaning I sat 6th graders first, then sat 7th graders, then sat 8th graders. And seated the same number of students in each row. If there are 48 6th graders, 40 7th graders, and 32 8th graders, how many students were seated in each row? This has to do not with LCM. I'm not finding their least common multiple. I'm finding their greatest common factor. Now, take a look at this. I'm going to take 48. I'm going to do the prime factorization of these 3 numbers, excuse me. So we have 48, 40, and 32. Well, 48, what times what is 48? I'm going to go with 6 times 8. You can use 4 times 12, that's fine. You can use 2 times 24, it'll break down the same thing. Breaking up 6, it is 2 times 3. These are both prime, so I will circle these. I go to 8. Prime factorization 8 is, well, if I think of 2 times 4, I will then break up 4 into 2 times 2. If I look at the prime factorization of 48, and I'm going to write this as a string. I'm not going to write an exponential notation just to kind of show you why. So this is 2 times 2 times 2. So I have 1, 2, 3, and another 2 times 2 times 3. Let's double check. 2 times 2 is 4. Times 2 is 8. Times 2 is 16. Times 3 is 48. Okay, good. Let's go to 40. What times what is 40? I'm going to go with 8 times 5. The reason I'm doing that is because 5 is a prime number, and I'll stop right there. Let's break up 8. That's 2 times 4. Let's break up 4. 2 times 2. Okay, now I have 1, 2, 3 2's. 2 times 2 times 2, and I have a 5. Just writing prime numbers down. So 2 times 2 is 4, times 2 is 8, times 2 is 5. Or excuse me, times 5 is 40, 8 times 5 is 40. We're good. Let's go to 32. I'm going to go with 4 times 8. I'm going to break up 4 first because it has 2 prime factors, 2 and 2. Let's break up 8. Well, one of the prime factors are 2. 4 is not prime. And we have 2 and 2. I have 1, 2, 3, 4, and 5 2's. So 2 times 2 times 2 times 2 times 2. Now, if I'm writing this in exponential notation, it would be 2 to the 4th times 3. This would be 2 to the 3rd times 5. This would be 2 to the 5th. The reason why I'm not writing in exponential notation, when I'm looking for the GCF, I'm looking for the factors that they have in common. Well, let's take a look. 48 has 2's and a 3. None of the other 2 numbers have a factor of 3, so I'm going to cross it out. Let's go to the next one. 40 has a factor of 5. None of the other 2 have a factor of 5. I'll cross it out. Now comes the tricky part. They all have 2's in common, but what's the most number of 2's that they all have in common? Or how many times is 2? How many factors of 2 do all 3 have in common? Well, this one has 1, 2, 3, 4. This one has 1, 2, 3. This one has 1, 2, 3, 4, and 5. I'm going to go with this. There's 1, 2. There's 1, 2. There's 1, 2. They all have at least 1, 2. There's a 2. There's a 2. There's a 2. They all at least have 2 2's in common. Now we go, there's a 2. There's a 2, and there's a 2. Well, there's 3 2's in common. Now, this one has a 4th one. This one does not. It only has 3. So, this one has a 4th one, but not all of them. So, the most number of 2's, or the most factors of 2, if I call it that all have in common are 3. Now, 2 to the 3rd is equal to 8. What that means is how many students are seated in each row. There are 8 students seated in each row. And if I sat the 6th graders in rows of 8, that would give me 6 rows of 6th graders. If I set the 7th graders in rows of 8, that would give me 5 rows of 7th graders. And if I set the 8th graders in rows of 8, that would give me 4 rows of 8th graders. If I were to type this out, there are 8 students in each row. Oops. I will have 6 rows of 6th graders. How ironic is that? 5 rows, not foes, rows of 7th graders, and 4 rows of 8th graders. Okay, hope that helps you out with those 2 problems. Take care.